Hello Year 8, so it's another lesson on matter. Let's get a move on. So today we're looking at floating and sinking. Now the outcomes, so by the end of the lesson you need to be able to describe and explain what happens to weight in water. You need to explain why some objects float in water using your knowledge of forces. And finally, explain how density of water can vary. Before we start, we need to do a few things. First of all, turn off your phone or put it in a different room. Don't have any other tabs open on your computer. Answer all the questions, i.e. pause the video if you need to. You can always rewind and listen again if you are not sure. And finally, do not give up. To start you off, guys, I want you to do this do now task. Okay, it is a KPI task. Do it by yourselves. You have roughly 10 minutes. Obviously take longer if you need to, yeah, it's not a big deal. But 10 minutes it is. Now using green pen, I want you to assess your answers. So this slide has all the answers, okay? Questions 1 and 2. So mark your work. Assess it, improve it. You know the drill. Now for those of you that did the extension questions, here are the answers. Floating and sinking. So we've already seen that some objects, okay, that have a lower density than water will float. So for example, when you go to the swimming pool, the instructors will give you floats, things that you can hold on to, or armbands which contain water. Now these have a lower density compared to water, hence the reason why they float. Now, question is, what makes these objects rise to the surface? What makes these objects or an object sink? It's all linked to density at the end of the day. And this is what we're going to look at throughout this session. We're going to look at something called upthrust and weight. Now weight is the force of a planet's gravity trying to pull an object down to the centre. Okay? Any object that is not at the centre of the Earth's gravity experiences a weight. Okay? Weight is the force of a planet's gravity pulling an object down to the centre. Now, in water, there's an opposite force which is called upthrust. Okay, upthrust is the upwards force exerted by a liquid on the object. It's water particles hitting an object and pushing it back up. Weight is acting downwards, upthrust is acting up. Let's take a quick look at forces. Okay, a scientist investigated what happens to the overall downward force of an object when placed in water. Okay, so what she did was she took some objects. Okay, she weighed these objects in the air. She found out what the forces were, so what the weights were. Then she placed them in water and she measured the weight again. Now, quick little task for you. I want you to write down what you think happened. Did the weight increase in water? Did the weight decrease in water? Or did the weights of these objects stay the same? And then write down a little explanation of why you think this, whatever your answer is. So to help with this task, if you haven't already done so, I've given you a few key facts. The first one is, upthrust is less in air than it is in water. I know earlier I said upthrust is where water particles push up an object, but upthrust is also where air particles push up on objects. Okay? Second key fact, objects will float if the overall force on an object is 0. So, if the upthrust and the weight are equal and opposite, then the object will float. It might float on top of the water, it might float below the water surface. Third fact, objects will rise or sink if they have an unbalanced force on them, i.e. the weight and upthrust are not equal. Just 3 facts to consider. Now then, on this slide, we've got a table with the objects and with their weights in the air and their weights in water. Now, I want you to answer these questions, okay? I want you to write a conclusion by answering the questions 1, 2 and 3 on the slide. Use the data in the table. Do that now. Pause the video if you have to as well. Now, I'm not sure if you can remember, but we can represent forces acting on a diagram We call these diagrams free body diagrams. Well, that's what we call it at GCSE. But I might have called them at Key Stage 3, so Year 8s and Year 7s, force diagrams. Okay, so all a force diagram is, you have an object, a picture of the object, and you use arrows, okay, force arrows, to show the direction and a force is acting on the object, and you use the size of the arrow to represent the size of force, okay? So what I would like you to do is draw a free body or a force diagram to show the forces acting on an object which is floating in water. So do that now. Now to help you, okay, because I'm aware you haven't done this in a while, force arrows need to be drawn with ruler. You need to use an appropriate scale for the length of arrow. So for example, every centimetre of your force arrow is equal to 1 Newton maybe. You need to label your force arrows. So obviously we already know we have 2 forces acting on an object in water. So you've got weight and upthrust. And finally guys, if it's floating, that means the forces are equal to 0. So your arrows have to be equal and opposite and the same in size, okay? So do that now, thank you. Using green pen, assess your work, okay? So assess the force diagram you've drawn and assess the questions from the conclusion, questions 1 to 3. Do that now. Whenever we look at floating and sinking, the question that always comes to mind of a lot of students is, well, what about ships? Ships are mostly made of metal, iron in fact, so why don't they sink? In fact, you know, if I gave a lump of iron and you did some calculations, you would find the density of iron is 8 grams per centimetre cubed. Now the density of water is 1 grams per centimetre cubed. So the density of iron is 8 times larger than water. So how come iron ships float then? Okay, how come iron ships float even though iron is dense, well, more dense than water? To answer the previous question, we need to go back a bit, okay? Remember, density is equal to mass divided by volume, right? So the bigger your volume is, your density will decrease. Also, the shape is important of your object, okay? Getting the shape right is also important so that there's lots of opportunities for upthrust. If your shape is small, there'll be less upthrust. If your shape is greater, there'll be more upthrust. And also, don't forget, inside a ship we have lots of air, and air is, well, it's ridiculously of low density compared to water, isn't it? It's less dense by far. So all of these things add up, and that means ships, even though they're made of metal, can float. When you go to the swimming pool, if you lie on your backs, you'll find that you are floating, because what you have done is you've increased the surface area of your body in contact with water, so there's more upthrust, okay? So there's more water pushing on you. However, if you decide to stand in water, what you find is, because you're vertical, you start to sink. There's less surface area for water to push up on, so there's less upthrust. Now, I'm not sure if you're aware of this or not, but the density of water can be changed. Okay? You know how I said earlier, the density of water is 1 gram per centimetre cubed. Now that is pure water. Water with no minerals, no gases whatsoever. Okay? The density of water will increase if we add more salt to it. So for example, salty water has, well, greater density than normal water. Now for example, I'm not sure if you've heard of this area called the Dead Sea. It's somewhere near Israel and Russia or Palestine, that kind of area. Okay, it has a very, very high salt content. So what that means is, you go there, you can literally sit and read a book in water. Yeah, you can sit and read a book in water. That's how dense the water is. You can do a quick little experiment at home to test how changing the density of water affects the floating on an object. Now for this little experiment you need 3 glasses of water, salt and 3 cherry tomatoes. First thing to do is pour water into all 3 glasses, place the cherry tomato in each, Add salt to the first glass and gently stir to dissolve it until the tomato is actually floating on top of the water. Repeat for the second glass, but only until the tomato is suspended midpoint, and don't add any salt in the second glass. Okay, so once you've done that, you need to make a note of how much salt you added in the first glass, second glass, and obviously in the third glass you added 0 salt. Now, I'm not sure if you've ever noticed this, but on the side of ships, they have these things called plimsoll lines. What these do is they show the maximum depth to which a ship can be safely loaded in different zones and seasons. Okay, so for example, you've got a depth for tropical areas, tropical freshwater during the summer, the winter, because obviously all of these affect the density of water and how far or how much the ship will, float. I have a small writing task for you. I want you to describe 2 ways that the density of water can change. And for those of you that are very confident with everything we've done so far, I want you to explain the idea of density using particles. Okay? So to help you, you can use the words in the word bank: salt, temperature, particles, spaced, kinetic energy, mass, volume, density. You know what? I've even given you the density equation, okay? Where density is equal to mass divided by volume. Have a go at this task. Using a green pen, assess your answers. The answer on this slide in red. And not only assess it, but also amend it, okay? See how you can improve your work. Compare your answers to these model answers. And that will help you to progress further, okay? Do yourselves that favour. Well done. Now, this is for all of you, and it is really just to let you know how well you've progressed in this lesson. And good luck with it, okay? So all you have to do is just try the exam questions in your booklets. Do that now. Thank you. Now, before we finish, I just want to summarise everything we've done so far. First of all, the weight of all objects decreases in water. This is because the force of upthrust is greater in water than it is in air. Objects that float because their weight is balanced by the force of upthrust. If you add salt and increase temperature, this increases the density of water, which makes it easier for objects to float. Adding salt increases the mass of water in the same volume, so it makes the density higher. And finally, increasing temperature increases the volume of water. Even though the mass stays the same, it makes the density higher.